welcome everyone to our Mastering AI series, Gen AI in Software Development. My name is Soraya and I am your host for today. Yeah, a little bit about us. My name is Soraya. As I mentioned, I am the founder and the CEO of Sales and Marketing in ICU with combined experience in marketing, sales, market expansions, as well as consulting. I work in different countries with B2B IT companies such as Software AG and also F5 Networks, as well as Aramco. And today I'm accompanied by the other founder, Ziggy or Siegfried Ekstedt. He will later introduce himself and will take over for the presentation. And a bit about ICU. We're a company specializing in applied AI. We bring automation to the industry to enable better and healthier community. So together we design, prototype, and developed customized AI software, but we also provide platform for individuals to upskill themselves. So what is Mastering AI is a series of 5 sessions, or actually it's 4 because we had to cancel one of them. And this is the series that we designed for practitioners to be able to adopt AI in a strategic manner. So we developed different use cases for you from sales to marketing and software. So you can start implementing the AI technologies right away. So that's all from my end. So I will hand over the session to Ziggy right away. Please introduce yourself and take over from this point onwards. Thank you.
Thank you a lot, Raya. So yeah, I'm Ziggy. Also founded ICU, doing more of the technical work and been in the larger data and AI space for about 10 years now, and started classically as data analyst and then went on working as a data scientist, and then gradually got deeper into software development for data and AI applications. And today I'm not only having the company, but I'm also working for a research institute, Fraunhofer Research Institute, where we look at a lot of use cases for AI, and some colleagues at the institute are also busy on developing open source large language models that are specifically focused on European languages. Token 7b is the name. And our inspiration for this whole series was to focus on showing what AI can do, yeah, but not stopping there, and actually showing real cases, or as real as we can make them. So bringing some data, bringing some prompts. We try to work with generative AI because you can actually do it yourself with the tools that you have. And then you will have plenty of ideas after this session, I promise, how to get going with AI in general when it comes to the larger discipline of software development, and how you can leverage Gen AI for that. And we have done the same with, just as Soraya said, with all of the other functions that you have across a business: sales, marketing, customer service. And look up the videos on our YouTube channel, for instance. Quite interesting what you find there. You will also find all of the presentations, such as this presentation. We will all provide it, and it's available, therefore cannot miss. All right, so this is as we see it, because like software development is a big category. We think it is, yes, of course, something that's relevant for the tech team, but it can also be relevant for those who take care of, let's say, the product or the project. People from quote unquote business or management. It could be the product owner, product manager, project manager, um, such a role. It could also be relevant for an entrepreneur or leader who is taking responsibility over the larger process. We say that you should treat this whole session as a tutorial. So pick up these exercises and examples that we show. Try it yourself. If you have any question, drop it in the chat here. We will try to get back to that. Ask in the comments of the video. We will also try to get back to that. Stop the video at any time and have a deeper look, or check the material, because we share the material. You can zoom into it. You can read into it, because there's plenty of information. Now, let's get set up. Last time, we already started our fictional case of Sphere, which is a product that we made up. It's a software as a service product, a CRM platform, the Connect Sphere, and it's next level, next generation, cloud-based, really, really cool thing. And what it has as its core, let's say, selling point is that it's meant for B2B companies that want to manage customer data in a more integrated way. So integrate different sources. You have a unified customer view and so on. Therefore, the product has two major functionalities: data unifier, which offers a vast library of connectors, and you can have all integrated, be it your marketing platform, sales tools, ERP, customer support data, data warehouse, whatever that may be, as well as, and that is on top of it, a smart engine that intelligently leverages the data that it all integrates there. And now, what we had in the past or previous sessions, where we set up the sales for our fictional product, and we figured out what marketing to do and how to treat the first incoming customer support issues, we now have the challenge to continue innovating on our product and also scaling it. So us as the development team, we now need to face like growing complexity, right? Because we have more users, functionality, or the features are also growing in volume, in complexity as well. We have a lot of new ideas, but we need to maintain the quality. We have some technical depth, and everything happens as we try to keep a high pace to match the market demand and work on the incoming customer feedback. Challenging times for us. And some of the issues which we could particularly face are that we need to prioritize what to work on and need to have a feeling for the impact. But that's uncertain, isn't it? So we don't really know what ideas to work on, where's the biggest technical depth, and where we, with high confidence, can decide what feature to build next. Then we also need to plan what we want to work on. We need to estimate how much effort is that, so that we make sure that we deliver things on time and don't run into some issues of unpredictable sprint outcomes. Code quality is very, very important as we scale up our overall product, and we want to make sure that it's consistent, that we build with security in mind, and we have best practice always in place, even if the team is growing and the code base as well. It's not too unlikely that we will have new hires, and we want everyone to work just as the core team that started out and made the first best features. We want to keep a high quality on documentation as well. Our APIs need to be documented. We have a lot of integrations. There is some internal design documents. There's some maybe user-facing release notes that we pack on some website and so on. It all needs to be accurate, needs to be up to date. We change something in our code, it needs to reflect in the documentation. All needs to be done. And lastly, we want to translate requirements that we get from customer feedback to code. So how do we convert user stories or product requirements into functionality in a way that everything is clear and well specified for our developers? That's a lot of issues, and this also motivates the agenda for today, where we want to leverage AI to tackle all of these. We want to start with finding the right use case because, well, if AI is supposed to help us, we have already seen that we have a lot of issues to work on. What issue should we work on first? So how to find the right use case is the first agenda point. Secondly, deciding for the first project. Then starting the prototyping process. We will also show demonstrations, 2 tiny demonstrations of how an AI-powered process could look like. And then we also will tap into the field of evaluating a prototype. Let's start with finding the right use case. In order to structure that whole topic around what an AI-powered process or product is all about, there is one concept that is very interesting for you to understand, and it is the AI flywheel. Comes from Andrew Ng, that's the gentleman on the lower right corner. And it basically is set up around 3 cornerstones or 3 anchor points, which are the users, the data, and the AI. So let me explain what it is all about. Let's assume we start using AI by integrating AI into one of our development issues or a step in our development lifecycle. It could be AI to help us draft unit tests, or it could suggest code snippets, it could highlight, or it could help us with documentation writing, whatever it is. And as it's leading to slightly better code quality or some faster initial development, people start to use it. This is where the users come into place. And as developers see that these AI tools speed up some task or improve some output, for instance, they have fewer bugs or something else, more team members will use it. And then we collect data through that. So every piece of code that is written, or every test that was run, every bug that we found, every successful AI-assisted task becomes data. And our AI tool, whatever that is for the moment, will learn from that and it will help it to feed that data into the next component, which is the AI. So with more data from our development environment, our AI tools become refined and better. So it could be that our AI test generator becomes better at creating relevant tests for the unique architecture of the Sphere product. It could be that our code assistant learns Sphere's specific patterns and APIs. It could be that AI starts predicting potential bugs in the Sphere code based on the historical patterns. And this, of course, makes the overall experience for our users better, which will lead to them using this tool more, which will lead to more data, and more data fuels a better AI prediction mechanism, which leads to more users, more data, better AI. And this is why it's called the flywheel, because while it might be hard to get it spinning at the initial phase, once it starts spinning, it is highly likely that it just rotates quicker and quicker with increasing speed and velocity. So this is something that, as a core mechanism of AI supported systems, we need to keep in mind if we want to conceptually design the same. All right. Knowing this, we want to have this understanding as entry points on how we want to design AI use cases. So there are possible entry points that you could have across all of the anchor points. We could start with a product focus with the app or the tool. And here we could ask ourselves what developer assistant would be like a game changer for our developers. Um, we could ask what would improve the quality a lot, or maybe make us a lot more efficient. We could also check what expertise we want to leverage, or what would be just like fascinating in terms of intelligence that we could bake into it. And we could also just look into some routine tasks potentially. These are all, let's say, questions that you can ask yourself in reflection to come up with something. You can also start on the anchor point of the user, focusing on the Sphere developers, and could ask yourself whether there are some development tasks that could, if we automate them, save a lot of time for our developers, or whether there are some frustrations currently that we could take out, whether there's anything that people are struggling to make sense of, finding the right information, for instance, onboarding processes, or it's just something that takes a lot of time for our developers to get cognitively set up and going. Back to Andrew Ng as the originator of all of this, he says, focus on value and creating value for users, which is why we will stick with this category first. So if we focus on users, we of course want to focus on solving problems for Sphere developers and the leads, meaning to say tech leads. One thing that um, we can often see is that we have a tendency to reinvent the wheel here. So we could ask ourselves, how could AI help us with the fact that often our developers write the similar boilerplate code for common tasks? And isn't there something that could be detected by AI or just be helped with by generating code or so? Then this documentation topic. So, what are the most painful and neglected parts about the documentation process? Could AI assist in keeping these parts updated uh, based on every single code change that we do in an automated fashion? Test writing, we all agree tests are important. We need to have them, but it's time consuming, and writing them at a consistent quality takes a lot of not only time, but also energy. It's draining. But couldn't AI help us with this practice as well? Code reviews. So, where do code reviews for new features um, get bogged down? Where do they just take too much time? Can't we check for something that's very common as an error, style inconsistencies, potential performance issues, and so on? The onboarding process, particularly for us as a young company, we want to grow fast. And we, of course, have new hires. They need to be familiarized with our code base. So can't AI provide some sort of guidance or answer context-specific questions for new joiners to ramp up quickly? And lastly, can AI potentially help us with that issue where we just feel like lost in translation? It was an initial requirement from the product team, from customer feedback, and then the translation into the actual technical implementation just didn't match the expectations. So can't we somehow figure out how we can provide these technical specifications with more precision? That was already quite a set of potential use cases or projects that you could tackle. And now you wonder, how should I decide for my first project? Valid question, particularly if you work in a team setup and you want to coordinate. You don't want to um, make the wrong decision, right? So you want to take care of that process. One approach that you could do is to work with an evaluation matrix and at least have these two scales that are sketched out here, value and feasibility. So it's like more the economic and business category, and then feasibility more relates to the technical implementation. And in our first session, which was actually sales focused, we talked a lot about this topic, what potential categories for evaluation um, dimensions you could set up. And you should, if you're interested in having a deeper dive, look into the first session of our Mastering AI series. Here, this is a little more like in all uh, shortness, a little summary, I would say. At least focus on value and feasibility, and then, of course, go for the upper right corner and the other quadrants handle with more consideration, such as how can we reduce complexity if there is um, the high value but low feasibility, and how can we get the most out of the category where we have low value but it's very feasible. If you struggle with defining a structure for use cases so that it's easier for you to evaluate them, you can really just ask an LLM to help you with that process. We have demonstrated that in a small application that we hosted on Hugging Face Spaces. So just a use case structuring. Go and check it out. It's all open source. Help yourself. It's a little app, but cool. All right, back to our um, use cases. Let's pick one. And what I found interesting was the case about test writing for the moment. So let's look into that. Tiny demo. So let's imagine the following scenario. We have the lead engagement scorer, which is a piece of our software, a module. And we use that for calculating an engagement score for leads based on various activities like email opens, website visits, demo requests, and so on. Keep in mind, we have a CRM system, and it's one of our AI smart engine components. The problem that we face here is that this module was developed quickly. We're a startup, right? So things happen. And while the core functionality works, the unit tests are a bit sparse. So they mostly cover the good case practices, good data, expected outcomes, but they neglect edge cases or error handling. So that means that bugs could slip through, especially in a new engagement type. So we onboard a new customer, they do something unexpected, and then a little bit of a hiccup. So can't we have tests written for us that represent a more comprehensive test suite for this particular module? This is our setup. Now, I am working here with a fully fictional setup, so I am creating some mock code that we just have a very, very shallow look into. So let's imagine it's Python. We have our lead engagement scorer. It has different functionality, and let's say there is some function that would calculate the score of the total engagement scoring, that is, and it does that for an entire list of leads. And then there's also another function that gets the score for a given category. Sorry, that categorizes the score into a category: cold, warm, hot, which will be used by the prior function. And we don't need to read in all of the code here, really, in order to understand what we are actually testing here. Again, this is a little bit of a mock-up scenario. Here's our test case scenarios for the lead engagement scorer, and we have calculate score happy path, and for the category hot we have something, and for category cold we have something. Very, very simple setup. And yeah, the issues that we have is that there are no tests for empty or invalid input to calculate score. There's also no tests for unknown activity types. What if the max score is breached, and so on. So this is the scenario that we're working on. Our engineers were writing down the tests quickly, and we are now wondering, like, what could we do with the use of AI? Let's set up a little system for that. So I will define a system prompt, and then with a user prompt, we will tackle the particular issue. A system prompt helps us to set up the overall context on how our Gen AI assistant or agent is supposed to act. So here we direct it to be a test engineer. And we also highlight that its primary task is to generate comprehensive and high quality unit tests for Python code. It already is quite specific. using the unit test framework. So here we are narrowing it down to be fully focused on Python, our product, and how it's set up. We also guide it in terms of what tests we expect. So happy paths, but edge cases we want to focus on, error handling, should be clear, should be readable, should be complete. This is the overall setup. And now let's see how this system is prompted. At first, we provide the entire Python code, or I should rather say the relevant Python code. So we focus on calculate score as the function that we want to create the tests for. And with this code, we give an instruction to generate additional unit test cases for the code above to improve its test coverage, focusing on edge cases and invalid inputs that are not currently covered. Assume the existing tests already cover a basic happy path. Actually, you could have just pasted the Python code. Here, this instruction is a little bit of, making sure that it knows what to do. But given our system prompt that we have already defined on the left-hand corner, it would have been able to work with the Python code pasted in solely. Let's see what it has done with that quite a bit. So for disclosure, I'm using the Gemini 2.5 Pro model. No particular preference to this very particular model here. In the past sessions, I have used different model providers, and I think I have not used Gemini in a while, so I just thought like, okay, the rotation is now on Gemini. So just try other models and see how the results would differ for your setup. I would be eager to know, and always let us know in the comments, of course. And you see that we got a lot more use cases. It's like 1, 2, 3, 4, 5, 6, and so on. And also for different scenarios, such as what if there are no activities in the list? Or what if the activity type is unknown? What if there is a 0 count? And so on. So you see that the test code is getting a lot longer, and that is quite common. That test code is a lot longer than the usual original code. So we're at that point, at first, we're happy. Now, as we have already started into working with Gen AI, and I've already given you some insights into how I have set up the prompts, you might wonder, okay, this this process of prototyping through prompting, setting up my own experiments, how do I actually do that? Very well question. Getting started with experiments should go following the principle to just to just build enough to understand whether your initial assumption was right. And here we highlight that you should really start simple and cross out anything that would lead you into a complex setup. Therefore, first, go and focus on prompting. I would also encourage you to just make use of uploaded data in your prompt setup instead of using a RAG system or so. So if you have some information that you would need to that you want to use as external knowledge that you want to provide to the system, think of how you could potentially copy paste that data into your prompt. So you set up something like a naive retrieval process or a naive RAG system. So all in all, focus on pre-trained large language models and prompt engineering, and don't go into training models yourself or fine-tuning or whatsoever. It's not necessary these days. When it comes to prompting itself, since it is so central, there are a couple of recommendations how you can do it best or things that you should not do and so on. Most of the model providers have very, very thorough guidelines. I should say that all of them have guidelines, and some go deeper, providing more examples, are more explicit. Some leave a couple more degrees of freedom. But when it comes to the prompt structure itself, then we usually have a common pattern that is highlighted across the board, and it is that you should provide what role or persona the assistant or the LLM should take, what's the goal, what's the instruction. You can provide some examples. You can also provide some output format expectation. How should the output be structured? And provide context, just enlarge to understand what the task is about. Since it's already highlighted in the lighter color, providing the goal and instruction is central. You should always do that. The other parts are more optional. There are also other optional parts, but these are the, let's say, most common ones. Something that you can consider if you have a lot of context data, that you put that first and then put the instruction second. Why is that so? It's because the AI systems or the chat assistants, they, when they work through your prompt, they read it top to bottom, and then what's at the bottom is top of mind. Therefore, if you have the instruction rather at the lower end of your prompt, it's easier for the model to recall it, let's say, or to work on it. Good. One thing that you can look up as well is our prompt lab, which is all about prompt engineering. We had 5 sessions which covered different aspects of prompt engineering. This slide actually is from the very first session, which just covered the basics. We went into a whole lot of more topics. Very, very cool stuff. Look it up. Back to Andrew Ng and his AI flywheel. So far, we have looked on the user focus, but there's more, right? There's also the data focus. Let's look into that. So if we focus on data, how to leverage, let's say, our code base and Jira and our CI/CD logs and whatnot, we could potentially make use of that, isn't it? So what patterns could we, for instance, find in the code base itself? Is there something in the Jira ticket history where we could find like common pitfalls or so? Is there some data in the CI/CD pipeline that we can make use of when we think of optimization? How about the comments and commit messages that we have with the code reviews? And potentially, if we have some bugs reported, can we learn something from that for future potential bugs? This is very interesting to look at data in general, the data that we have available, because this is something that also Andrew Ng would agree on. AI development becomes more and more data driven. Since we do here just experimenting, we use prompt engineering, we don't train our own models. And therefore, we don't focus on the AI models so much, we focus on what data we provide these AI models with. And therefore, we need to think a lot about the data. And so this whole aspect about data becomes more central. All right, so since we are keeping that data focus, what potential cases could lie in this context in order to leverage the code base and the development artifacts? We could view our code base as a knowledge source. So what common coding patterns, architectural decisions, or custom libraries um, exist within the Sphere code base, and could AI, recommend something from there or replicate that for some new feature in development? Our bugs and issues that we have accumulated over time, is there any pattern in there? Common errors, modules that frequently have issues, some conditions that have led to a failure. For sure, AI can make sense of it. Tests, well, we have just looked into it. Sometimes we only have very few tests, and this is data as well. So the test coverage and maybe also the results of the tests that we have run, there's some virtue in that, isn't it? So we could identify areas with insufficient test coverage or suggest more effective test strategies, for instance. What about our reviews and the code commits? There must be some best practice or common mistakes or some preferences maybe that lie in that historic data. Next point about performance, right? So if we feed AI performance data from our deployed product, could it identify code sections that are just bottlenecks and then therefore suggest optimization for frequently used but inefficient parts of the platform? And lastly, for the dependencies and libraries that we use, what can we learn about this third-party libraries and dependencies across the Sphere platform? Could AI help us maybe identifying outdated ones and help us with security vulnerabilities in the dependencies and suggest more optional alternatives, more optimal alternatives? Let's focus on that and look into it. I found it a little bit interesting to have AI looking into it. Tiny demo, dependencies, and library usage. So we have a lot of code, we have the libraries, and it's a growing code base, right? And it's growing quicker and quicker, probably at accelerating speed. And what we want to do is identify the outdated libraries. Potentially there are security breaches, as I've just said now. And don't underestimate that in terms of how quickly that can happen and how quickly this also leads to technical debt. So we want to cut that out early in the process and make sure that we never run into technical debt. All right. The mockup code that I've generated for this looks a little bit overwhelming and is all right. We don't go through everything here. We have, let's say, some setup with the libraries that we use. It's in the requirements text document, and we have the reporting engine as a module, which just stretches out over 3 different screenshots that I've taken to demonstrate it here. My point is, it can be a lot that you would need to swift through if it was your task to keep all of this updated. And there are so many potential pitfalls that could lie in your code. And for us as engineers or as a team, it's really hard to get our head around it. So what could we do? Here is some setup that could potentially help. The system prompt that I've set up here is an software engineering assistant that is supposed to analyze Python code snippets and dependencies to identify potential issues related to library versions. So again, very specific, right? Python version compatibility, vulnerabilities in general when it comes to security, and opportunities for modernization. So we want to focus on providing actionable feedback that helps developers maintain a healthy, secure, up-to-date code base. And when analyzing the code, we want to consider specific library versions from the dependencies. This is the system prompt. And then when using the system, what we provide is, on the one hand, the dependencies, and on the other hand, the code. So here, to represent how that could look like, I have just basically copy pasted it here. You could do the same, or when you use a code assistant in your IDE, you can do it similarly by highlighting it and asking it a question such as, are there potential compatibility issues, warnings, performance considerations with this Panda version compared to newer versions? Explain any potential issues. So this is a very specific question, right? And we could have other specific questions as well, such as considering the Python version that we have here, which is 3.9 and above. Isn't there any more modern Pythonic way to achieve the same result? Or what advice would you give regarding the fact that we use Pandas 1.1.5, which is a little bit late, got released to 2020, for a project that has been actively developed in 2024, wants to continue into the future. So what shall we do? So these are very open-ended questions and can help you with your overall mission to modernize your code. Here I have an exemplary response. It is, again, a Gemini created response for the first question that we have just seen, asking about the Pandas version, whether there's anything that is potentially an issue. And yeah, it has analyzed a couple of things here for us. No need to go into that. But what I like here is that we get an explanation that is really thorough, get a recommendation as well. And if we put all of this information also into our internal design docs or provide this feedback when we onboard people, when they ramp up, when they potentially want to groom their development skills, that can really be a game changer, because instead of waiting for a senior developer to give you a response, you get access to this expert knowledge very, very quickly. That's really cool. One thing is left though. How can we actually evaluate these prototypes? We have just seen there are some recommendations, maybe there's some code that is being suggested and so on. Is that actually any good? One way you could tackle this is by using evaluation frameworks. This is an exemplary framework. The major model providers offer them. OpenAI, for instance, they have the evaluations framework openly published on GitHub. You can use it there as a Python library, for instance. And you can also use it through their platform. But yeah, again, it's basically open source. And here you can set up tests with given test criteria. So in order to make up your mind, what could such test be, or how could a testing criteria look like? Let's have a list. Let's have a look through this list here. We could check for whether it's actually factual or whether the system hallucinated, whether we have a given output structure adhered to, whether it matches a schema that we have defined, whether it matches some criteria that we have defined, whether there is a given quality in the text that we have set. Sentiment, we could check for a specific text that we would expect. We could check for semantics. We could also create our own prompt. So it's using LLM as a judge, let's say, in this regard. So plenty of things that we can set up automatically, even using these frameworks, but at least draw reference from or inspiration from these frameworks, from how we should evaluate if we get a response from an LLM. Back to our flywheel, because while we have looked into data, while we have looked into users, you might want to say, hey, this is an AI-focused session, and you have not yet talked about AI as an entry point into our use case journey. Let's do it. So focusing on AI, we could have plenty of entry points. So what could be some questions that could come to our mind? Where could Gen AI have the most impact on our code or documentation creation speed? How can maybe NLP processes improve the clarity of our requirements, specifications? How can we predict bugs, for instance, if we use the predictive capabilities of artificial intelligence? How can AI optimize the testing process in generation as well as execution potentially? And how can we write smarter reviews or refactoring suggestions for Sphere? So in that regard, AI, very, very versatile. Beforehand, we talked about the data. And yeah, well, also take it from Andrew Ng. If data is the new oil, AI is the new electricity. It's very, very versatile, just as electricity is. And we can apply it to a whole breadth of uses. Let's look into a few things. And I'm also clustering it into different types of AI. Let's focus on the first here. Classic machine learning could be used for just effort estimation and task prioritization. We could imagine this to work in a list style of fashion where AI just analyzes historic data from Jira and then predicts with some degree of accuracy the effort for a new development task. Maybe we can also predict bugs and anomalies. This is also very analytical. It's relatively easy to manage and set up. Here we would predict the likelihood of bugs to occur from past bug data. We can go beyond that and uh, have test case generation for AI-powered testing. Don't need to look in, we don't need to go into that so much because we have just seen how it can actually be done. Requirements specification is really, really cool, particularly if you need to handle two different worlds, and that translation effort between technical and non-technical people is a really, really good feature of AI. It does that with astonishing result, if you ask me. Then code generation and assistance. Well, that used to be a very big topic 2 years, 3 years ago when Gen AI started. Now we already shrug our shoulders and be like, yeah, well, what's so cool about code generation? That's like the most mundane thing ever. We sort of forgot how astonishing that actually is. But yeah, that is still a thing. Of course, code generation is important. And lastly, documentation and summarization of your code base. Um, maybe you have a very complex section of code that you want to have summarized for documentation purpose, or draft the release notes based on the history of your commit messages. Let's wrap it up. One thing that you might have understood from our tiny demos and the way how we approach the topic is that it's actually not so complicated. And the workflow can also be done iteratively. Here we have like a suggestion for a relatively generic but still valid workflow. Just start with the initial prompt, have the response generated, then evaluate, good enough, not good enough. If not, why? Analyze. Maybe if you have metrics that you can make use of, or evaluation criteria, be explicit what you want to have improved. Adjust your prompt, have it generated again, and then check. That is it. We have come to the end of today's agenda. We have looked into how to find the right use cases, decide for them, how to get going with prototyping. We have had a look into tiny demonstrations, and we also touched on evaluating a prototype. With all of the issues we have with software development in our young sphere company, our fictional company, well, AI will probably help, but we will still continue to have a lot of work. I think we can all agree, but I can also, with a lot of confidence, say that it will give us a big boost as we tackle all of these. And that is it for today's session. I give it back to our host, Soraya.
Thank you so much, Ziggy. I must admit that that was pretty technical, but very, very interesting how you presented it. And yeah, so thank you so much. And for everyone who has questions, do not hesitate to drop us a comment. And this is our last session of the Mastering AI series. So do not forget to check all of the videos that we have posted on YouTube and follow us for more sessions. So with that, I will close the session and we will see you again in the next series. Thank you.